is an exam. There is an exam titled Class Assignment 1. Is this in Class Assignment 1?
Class assignment 1. Is it?
Yes.
Oh, sorry. It's okay. Uh, where do you find that class assignment 1? There
It's
is.
chap it's in the chapter 2 block and at
Yes,
in the
yes.
last.
Class assignment 1. There is in class assignment, right? That is in class assignment 1.
But
Yes.
there are two in-class assignment in chapter 3. Like in-class assignment
No, that is one is was assignment 1. Okay.
okay.
Assignment 1, and yes, there are two in class assignments in under chapter 3, but the first one, as I took it instantly, so
Oh,
maybe I won't count that. Okay, because
oh okay.
many of you requested me not to count that. So I am counting in class assignment 1, and then under chapter 3 in class assignment 2 on TCP, that will be
Okay.
counted. Okay, and then today we will take in class assignment 3, and then after 1 week we will take in class assignment 4. So that is about taking 4 in class assignments. And already you have submitted one home assignment, and you will submit another one by 29th May. So
So how
all
many in-class
assignments,
assignments will be counted?
home assignments will be, both will be counted. There is no option.
স্যার একদম প্রথম
Or
একটা আমরা ক্লাস টেস্ট দিয়েছিলাম, সেটা কি কাউন্ট হবে? আমরা এলএমএস এ যেটা দিয়েছিলাম।
uh, uh, Theoretically that should not be counted, since we are not taking any more quizzes. But if anybody needs that, like 3
স্যার
out of 4 in class assignments, please mute your microphone. Okay, in that case, if anybody needs, I will count that for those who will need that, right? In that case it will be
স্যার
3 out of
সেটা
5.
আমাদের
স্যার একটা কথা বলতে পারবো?
You understand? 3 out of 5.
স্যার আমরা যারা স্যার প্রথমটাতে স্যার ভালো করছিলাম স্যার, আপনি যদি স্যার
Sorry, I cannot hear you. Yes, Ahmad, who are talking?
স্যার শাহাদাত।
Oh, Shahadat. Okay, just can you increase your volume a little bit?
Yes sir, you can hear me now?
Still very low.
Maybe there
I
is
don't know
some-
why, because I can hear others' voice very good.
স্যার
Yes,
স্যার মানে আমাদের যেহেতু স্যার টোটাল স্যার 3টা কাউন্ট করবেন স্যার, সো
Yes.
4টা থেকে 3টা অথবা 5টা থেকে 3টা, এটা তো স্যার কারোরই ক্ষেত্রে কোনো সমস্যা হওয়ার কথা না স্যার। মানে যারা আমরা
right, definitely,
মানে সেক্ষেত্রে স্যার যারা আমরা প্রথমটাতে ভালো করছিলাম স্যার, তাদের একটা অ্যাডভান্টেজ।
ইয়েস স্যার,
right.
এটা অ্যাডভান্টেজ হইতো আমাদের জন্য প্রথমটা কাউন্ট করলে।
Okay, fine, no problem.
ইয়েস স্যার।
Uh, Actually, if anybody does good in 3 out of 4, then any other one is actually doesn't matter, right? So
Yes, sir, it
that's
doesn't
what
matter
I'm
actually.
saying. Yes, if you do good in 3 out of 4, then it's not doesn't matter. But
It
if
will be
you
okay.
need,
Yes.
actually definitely that means that will be counted. Just you can think about that will be counted. Okay.
স্যার
Yes.
স্যার ওই
Adnan.
গ্রেডিং এ একটা দেখলাম স্যার, ওই যে ইন ক্লাস ওয়ার্ক একটা, ওই যে সেকশন 3.4, স্যার ওটা মেবি স্যার ক্লাস টাইমে আপনি গো ব্যাক
Right.
এন আর একটা সিলেক্টিভ রিপিটের উপর একটা কাজ দিছিলেন স্যার, ওটা কি
Right,
কাউন্ট
right.
হবে?
No,
ঠিক আছে স্যার।
no, I've decided not to count that because many did not submit.
ইয়েস
So that's why I will not count that. So other than that, there will be 4 in-class assignments, and since we have taken one online quiz, if I count that, there will be 5. So 3 out of 5 will be counted. But in that case, no other option will be there. Okay. So even after counting 5 assignments or quizzes, if you still have some problem in marks, then you have to bear with that. Okay, so before the break, we have covered up to link state routing, right? We have done one hands-on example on link state routing. Let me just review a little bit.
Sir, I have a problem in exercise.
Yes. Okay. Okay. Tell me.
Sir, it is a question 7.
Question 7. Okay. Tell me.
Study guide, sir. Study guide slide.
Oh, study guide slide or PDF?
Sir,
This
PDF.
one, right?
Yes, sir.
Question
Sir, page number 7.
page 7. Okay. Page 7. Okay. Question 7.
Yes, sir.
This one?
question 7. Yes,
Yes.
sir. This one.
Okay.
Sir, we can see in the table IP address start from 128. That
Right.
means it's class B, right?
Right. Right.
And we have to match up to 16 bit, right?
Okay. 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 I got your point. Do you are you doing computer network lab now?
No, sir.
Oh, that's why that is the problem. By default, a class B network will have 16-bit network. Fine, but you can see here, that was your question probably. You can see here it's probably 23. So it's class B. Its network number of network bits should be 16. Why number of network bit is 23? Actually, I have given some hints during I think last or the previous lecture, the basic about IP addressing. By default for class B, 16 bits are network bits, that's fine. But if you find like 23 here, that means further 7 bits are used for grouping, dividing a network into a number of sub networks. So for the time being, those who are not doing lab, you can just assume the number of network bits given in the subnet mask will be the final one. So if I see it's a class B, it should be 16, but that is default. But in this example, number of network bits, how many? 23. That means just make sure, just understand that these extra 7 bits are used for creating subgroups under a major network. But you don't need to worry about that. Just make sure you will use 23 bits as network instead of default 16. So if given in the given question number of network bits, we call this subnet mask. Sorry, we call this custom subnet mask. Okay. So if you find 16 bits, that is default subnet mask. So 255.255.0.0, this should be a default subnet mask. But in this case, this is the custom subnet mask, and when there is a custom subnet mask, we'll use that subnet mask. You don't need to worry about the default 16-bit. Yes, is it clear? Is it clear to you, Yasir?
Sir, then how will answer the first one? Can you explain?
Okay. In that case, you from the subnet mask, you don't need to worry about 16-bit now. How many bits in the subnet mask given? 23, right? In
Yes,
the first subnet mask, you can find 23 ones. 254 means 7 bits. So 255 8, 255 8, 254 7. How many? 23, right?
Yes, sir.
So don't worry about basic or default. It is given 23 bits. You have to use 23 bits as the network bit, right? Now, what we do during the forwarding process, out of these 32 bits, first 23 bits must match. So in that case, you have to break down which octet? The third one, right?
Yes, sir. Third one convert to binary.
Right, convert binary, because 23 means 7 bits in the third octet should match, right? 8 bits in the first octet must match, 8 bits in the second octet must match. So that means for first 2 octets we don't need to actually convert, because
Yes, sir. I got it, sir. I got it. Thank you.
right. So
Yes, sir.
just you have to decide on which octet you have to convert based on this information. So I think those who are not doing lab, maybe you have some problems because you know class A, class B, class C. So the default subnet mask should be that. Why subnet mask is like this? Just make sure you understand that you have to use the given subnet mask, that is the custom subnet mask. And in that case, you have to decide which octet you have to convert to binary to match this. For example, in this case, for matching the first entry, you have to match the first 7-bit of the third octet. For the second entry, same thing. If first entry doesn't match, go to the second entry. Again, 168, you have to match with the first 7 bits. Doesn't match, go back to third. 166, again, you have to go 7-bit. In this case, this is actually same, but maybe this could be different. For example, 254, there can be 255, there can be 252. So based on this information, you have to decide. And if none of these entry matches, then you have to go to default. Okay, I think those who are doing lab, it's very simple. But those who are not doing network lab this time, you have to just go through a little bit to understand this. But always work with the given subnet mask. In that case, you don't need to worry about the class. Fine. So in the last class and the second last class, we have done, we have started section 5.2 of chapter 5, and we have done the routing algorithm. Just to review the things, routing algorithms can be classified according in two different directions. One is how fast do routes change. One can be static, and then another one will be dynamic. And another thing is what type of information or how much information every router knows. Based on that, one can be global and one can be decentralized. Global means every router will have the entire topology, entire database, like linked state algorithm. And decentralized means every router will have partial topology. That means it will have only the information up to the physically connected neighbors, not beyond that. So we have done one linked state algorithm, but we will do distance vector algorithm today. But before going to that, this is the thing we have covered. And then we have done one linked state algorithm from scratch. And in that case, as we say, every node has complete network topology before it starts to calculate. And there are some notations we have also used during our hands-on example. C means direct cost. D, capital D means estimated cost from the source to the destination. Because in linked state, we definitely know the source for which we are doing the calculation. All other nodes are possible destinations. Then there is another one, PV. PV means predecessor node along the path from the source to V. That means from source to V, from the shortest path, the immediate node before the destination will act as the predecessor node. Why you need that? To find the shortest path. Then there is another notation called N prime that contains the set of nodes already processed. So using these notations, this is the algorithm. You don't need to memorize this, but if you now come back to the algorithm, it should be clear to you what is being done in the process. For the initialization, you have to put the source in the N prime. That is the starting point. And for all other possible destination nodes, if the destination is adjacent to source, that is, for example, U, then you put the value there, the cost from U to that node. Otherwise, you put a infinite. So this is the first step. It covers the first step, and there is a continuous loop iteration. How many iterations? Number of nodes. So if there are 6 nodes, you have to perform 6 iterations. Already first one is done. So 5 more iterations. That means 1 iteration for each of the possible next node. How we can calculate possible next node? We will find a node that is not processed. Not in N prime means that is not processed. Okay, and that is not processed, and then we call this that node the current node. We put that node in the n prime, and then from the current node we try to calculate, is there any other path that costs less than the already estimated cost in the table using a formula. This is the formula until all nodes in n prime. So can you remember, we have divided the linked state routing algorithm into 3 steps. The first step was step 1. What was that? Anybody? What was step 1?
So creating table, next.
Calculate,
So create
discuss, trace,
table.
table, right?
Yes, sir.
You can see your class note that should be there. So step 1 is actually this loop. When this loop is finished, actually using 2 more steps in a very short amount of time, you will find the final forwarding table. So that is already done like this. This is the step 1. This is the first step. Then for every other step, select the one. See, find a not in n prime such that dA is a minimum. So after every step, take the minimum cost node. For example, X is here, and then place that node to n prime, and that will be the current node. And from that node, what are the possible next nodes? See from the database, and for each of the possible next node, apply this formula. Did you get my point? So we have done this already in the last class hands-on, so I am not going to that. That just I am reviewing if anybody has any problem. But at every step from step 1, you have to show all the possible calculations. So suppose if there are 3 possible next nodes, you have to apply that formula for 3 times, and you have to show all the calculations. And then after doing the calculation, in this case no calculation is shown, but during our hands-on example we have done it. So during your answer, in any case, in assignment, in any kind of exam, you have to show all the calculations. So after the second step, again take the smallest possible value, in this case 2. So take anyone, you can take anyone, you will get the final output same. Then again y will be the current node, complete this row, take the smallest one, again calculate, show all the calculations, and then finally when all the nodes, see at step 5, u, x, y, v, w, z. So all the routers, all the nodes in the graph is already in n prime. That is end of step 1. Okay, now this table will give us the forwarding table for you in a very easy and least amount of time. So step 2, you can just draw the picture like this. The red arrow indicates the selected one. That is the shortest path. So for example, if you think, okay, Z is the destination, the shortest path will be U to X, X to Y, and Y to Z. So this is shown in the least cost path tree, but in our hands-on example, we have shown in a different way, but the same thing. And then finally, from this tree, from this shortest path, we will get our final forwarding table. That means if U is the source, then you will go to V directly, and you will go to all other destinations through X. So this is our final forwarding table. Anybody has any questions? And there is one question in our homework too. So if you do it yourself, if you practice, it will be very simple. So that was about discuss trace algorithm. There is another example. You can see this, but I will not go through this. So any question on linked state algorithm? Anybody? No? Okay, our in-class assignment today, in-class assignment 3, you will be able to download the question at
Sir.
1:05 p.m. Okay? Yes, question?
Yes, sir. Sir, can you go to the same page?
Okay, linked state?
No, sir. Sir, I had that question I asked you.
Oh, okay, I'm going, fine. But before that, see, this is the link already created. So it will be available at 1:05 p.m. Okay? The exam duration will be 20 minutes. So it will be up to 1:25 p.m. Then you will have 10 minutes to upload 1:35. I think 10 minutes should be more than enough. Please be aware that it is creating a problem if you mail me. It's getting a problem. So I don't want to receive any script through mail. So that's why I am giving you 10 minutes. 10 minutes enough time. But if you start uploading at 1:35, you'll face difficulty. Okay, but you should submit in ELMS. So that's why please complete the exam by 20 minutes, and then as early as possible upload your scanned version. As you can see, if you understand the concept, it will not take long time. But if you don't understand the concept, then that will be a problem. In that case, 30 minutes will not be enough. So that is my suggestion. I don't want to receive any script in email. Okay, so if you, as early as possible, if you start to upload, there will be no problem. Okay, now Yasir, your question, this one, right?
Yes, sir. Sir, if there in subnet mask table,
Yes.
if there is 253 instead of 254,
there is
then
no possibility of 253 in any octet in subnet mask. Again, that needs a little bit of your understanding about subnetting concepts, since you did not do the computer network lab, that you have to ask your friend, or you have to go through some of the materials in the IP addressing used in the lab. I think that will help.
okay, sir.
So current consecutive ones থাকতে হবে তো
Right, because in subnet mask it identifies the network part and then the host part. There it cannot happen once host part has started, then again some bits are from network. So if you think about this, once 0 starts in subnet mask that represents the host, there can never be another one. So that's why if you say 253, that means there must be 1 after 0. That means you are saying, okay, this is the
Yes, sir,
host
1
part,
after 0.
right? It cannot happen, because if it is the host part, you cannot put any network part in the host again. So that is the specialty of subnet mask. Initially there will be any number of ones, but once 0 starts, that will be the host part. It can never happen that after the 0 there is another one. Got my point?
Yes, sir. That's mean consecutive 1 should be here.
Right. Once 0 starts, you can never have another one.
Okay, sir.
But in case of IP address, that can happen. But in case of subnet mask, that can, because subnet mask represents, right, in the basic part, I said every IP has two parts, right? Which part? Every IP address has two parts.
networking host
Right, one is network part, one is host part. So once network part finishes, then host part begins. Yes, it got my point.
Okay, so that's mean when there is a 252, that's mean
Right,
there will be
252
6
is
bit.
possible.
6
Right,
bit
6
count.
bit.
Okay, sir.
252 6 bit, 248 5 bit, 244 bit, 224
thank
3
you, I
bit.
got it.
Right? Okay.
Okay, sir, thank you.
Okay, thank you. Okay, so before our in-class assignment, let us finish the theory part of distance vector, and then we will do one hands-on in the next class. So distance vector, in case of distance vector, the main difference is what? The main difference is every node will have only the partial topology. Partial topology means if you go through here again, if you come here, for example, this is the same diagram, okay? In this case, if we use distance vector for whom? For u. So you will only know data up to v, x, and w, right? Only the cost up to the physical neighbors. And then what about the rest of the graph? That is not known.
Sir, oh yes, sir.
That is not
Yes.
that is not known. So this is the first difference, basic difference. Now, why this is important? Because see, in Discuster's algorithm, linked state algorithm, every node has complete topology. So when every node receives the database and then it starts the calculation, it will not depend on others, right? Because it has the entire database. So if I do calculation for u is not dependent on v, w, and y anymore, right? When it starts calculation. That means, but how it gets the entire database, that is a question. It must, every node must exchange information with one another. So there will be some time before every node will get the entire database, right? In case of distance vector, a node can start the calculation right away because it doesn't need to receive the entire database. So see the trade-off. Linked state needs some time to get the database, but then once it starts the calculation, it can do it very fast, because in that case it doesn't need to depend on others. In case of distance vector, a node can start the calculation as early as possible, but again it will depend on others because it does not have the entire database before it starts calculation. You got my point?
So distance vector example kunta?
Right, I am coming to the example.
Okay, sir.
That is the basic difference you have to first understand. So that's why in distance vector we will use another equation. I am coming to this later. Before that, let us first know the thing. Since in distance vector you will only see, or you will only know the information up to the connected node, right? V, X, and W. You will never see there is a cost 3 from X to W. There is a cost 5 from W to Z. You will never know that. Why? Because U is not directly connected to Z. Now, how distance vector works? This equation we call Bellman-Ford, because Bellman-Ford actually invented this algorithm. See the idea. The idea is at every step, for example, you will know a cost, an update from the neighbors. Who are the neighbors of you? Can anybody?
X, Y, W.
Not Y. X, V, and W.
I thought
X,
V
V,
was
and W.
Y.
Right. So X, you has 3 neighbors. So in distance vector, just you have to understand that only the neighbors will send the updates. Okay. The neighbors will send the updates. So that's why, for example, U is calculating the cost up to Z. So who is the destination? Z. Just assume, this is an example. Destination can be anyone. W can be destination, Y can be destination, but in this example, Z is the destination. So how many ways you can reach Z? Anybody? What are the possible options for you? How many possible options to go to Z? 1 or 2 or 3?
So more than 3 looks.
No, exactly 3. Why exactly 3?
Yes, sir.
Because there are 3 options, three neighbors. Number of neighbors. You cannot forward. See, during the routing, I have told you this this visualization. What is routing? Routing is calculating the shortest path. But what is forwarding? Forwarding to the next node. And if a node is not connected to you, how can you forward to that node? So you has only that number of options, that is the number of neighbors. Is it clear? Very simple. So if you has 10 neighbors, how many options?
10 options.
Very simple, 10 options. You have 5 neighbors, how many options? 5. Doesn't matter who is the destination. Doesn't matter who is the destination. Number of neighbors will be the number of options. Is this point clear to everybody? Because that is very important. Now, in case of linked state, if you remember, after applying every equation, how many possible values was there? Let us go back. See, how many possible options in the formula?
Sir, number of nodes minus 1.
No. How many possible values in every application of the formula? See, we are taking the minimum. Minimum of what? There are 2 options. One is the previous value, right?
Oh, yes, sir.
You can see here. One is the previous value and one is the value if we go through current node, right? If we go through current node, then DA plus current node to destination. So there are only 2 possible values in every application of formula. Is it clear?
Yes, sir.
That means doesn't matter how many times you apply the formula, you will get only 2 possible values. One value is the previous value already in the table and one is the value if I go through the current node, right? You have to make sure this. So there are 2 possible values only in every application of linked state. But in case of distance vectors, see, I just want to make sure you understand the basic concept. That's why I am just comparing with linked state, so it will be easier for you to understand the difference between distance vector and linked state. So now come to the example again. In Bellman-Ford equation, if you can see minimum of V, what is the V? Neighbors. So if there are 3 neighbors, how many V will be there? 3, right?
3, sir.
3. That this is the possible set of next nodes. So if there are 3 neighbors, this will be 3. If there are 10 neighbors, this will be 10. That means now for each possible next node, you will have 1 value. Now the formula is a little bit different. Now first the direct cost and then the estimated cost. But this is 1 cost. So how many V? If there are 3 V's, how many values will be there in the equation?
3, sir.
Very good. 3. If there are 10 neighbors, how many values? 10 possible values. And see, in every equation, in every possible value, there are 2 parts. One is direct cost from X to the intermediate node, and one is that intermediate node to the destination Y. Okay? So just keep in mind, there are 2 parts of each value. One is the direct cost, that is known. See, that is known. If you go here now, see, that is U to V. U is the source, Z is the destination, and there are 3 neighbors, X, V, and W. For each of the neighbors, direct cost is known, right or wrong? Yes or no? U to V, 2, known. U to W, 5, known. U to X, 1, known. Is it clear?
Yes, sir.
But what is unknown? V to Z, W to Z, x to z. So there are two parts for every possible calculation. Now from u to z, how many ways we can go from u to z? Tell me again.
3 ways, sir.
3 ways. To know the cost of each possible way, you have to know what? Direct cost is known, so you have to know the cost from intermediate node to z. See, dvz. This dvz means distance from v to z. dwz means distance from w to z. Distance means actually least cost. And dx to z means x to z, what is the least cost. Now, these 3 values you will receive from whom? From the neighbors. So after a certain amount of time, V will inform you that from me, least cost to Z is 5. W will inform to you that from me, least cost to Z is 3. And X will inform. You don't need to see the cost now. This is the formula. This is the algorithm. And the algorithm says neighbors will inform the updates to others. So by that way, you will know these 3 costs, right? Now see what will happen. So you has direct cost, you knows direct cost. Now you receives the updated cost, that is capital D, from V, X and W. Those are neighbors of you. Now you can get 3 possible values. Is it correct?
Yes, sir.
And then you will just calculate like UV, U to V2, U to W5, U to X1, and then capital D, it is informed by the neighbor. So it again calculates 2 plus 5, 1 plus 3, 5 plus 3. Which one is the lowest? Through X, right? Through X. If it goes through X. So that's why 4 is the lowest cost. If 4 is the lowest cost, you will send the packet to which node?
V number.
X, right? Because
Yes, sir.
X through
Yes, sir.
X,
Excellent.
Z is the minimum. So that is the idea of routing. But then again, think, in case of linked state, always there were 2 possible values. One is the previous value, one is the value with current node. But in case of this equation, Bellman-Ford, since every node knows direct cost up to the neighbor, and it is informed by the neighbor cost to the destination, then it will calculate, and for every application of the formula, it will get how many possible values depending on number of neighbors.
Neighbor.
So if there is another connection U to Y, for example, in this graph, if there was another connection from U to Y, how many values we should get? You got my question? If there is another connection from U to Y, that means how many neighbors from U?
4 neighbors, sir.
4. 3. Now if U is connected to Y, it will be 4. So there will be 4 possible values. So simply understand this equation as every node, when it calculates, applies the Bellman-Ford equation, how many values it will calculate? Number of neighbors. So if there are 3 neighbors, 3 values. But for each value, it will have 2 parts. One is the direct cost and one is the information from the neighbor. Is it clear? Any question?
So U to Y, 4 neighbors still.
No, if there was a connection in the graph from U to Y, if. But there is no connection now. But just for example, I said if there was a connection from U to Y, then in this equation we need to add
Yes, sir.
another
Yes, sir.
possible value, right?
Yes.
Just to make you understand. See, I have given so much time in equation so that it will be easier when you do some example, because we do some example and then we don't know the logic, it becomes a problem. So now if we know the logic, of distance vector and how Bellman-Ford equation is applied, it is very simple. See, node achieving the minimum, that is in this case we saw it is X, is next hop on estimated least cost path at destination Z. So that is the idea of any routing algorithm, to find the least cost path, and in distance vector it finds the least cost path using Bellman-Ford equation. Now there is another thing in distance vector algorithm. Since there is every node will have partial topology, in linked state every node has complete topology. So in linked state actually we needed to show only the table of the source, right? In case of linked state we needed to show only the table of one node, but in distance vector that is the characteristics, it will need more space, because every step you have to show the table of every node, because every node is dependent on other nodes. So showing only one single table will not be enough. So what is the algorithm, how it works? In the top level, each node will initialize its table. How initialize will show you, and then wait for the change in local link cost or message from neighbor. That is, it will wait from the update of the neighbor. As we said, capital D, when it gives the update, gets the update, after getting the update it will recompute, it will apply the distance vector Bellman-Ford equation, and it will see whether its own table is being updated. If there is an update, then it will notify the neighbors. This will continuously cycle down until when? Until there is no more update in any node. So for example, there are 5 nodes, they are exchanging information, doing it in cycle, but at a particular step there is no update in any of the nodes. Then we call this a converged state. In that case we can say, okay, network is now in stable state, now it can start forwarding the packets. And we don't know how many steps we need to become in the converged state. So it is said iterative, since it is in loops, it is going on loops, and it is also said asynchronous. Why? Can anybody tell me why it is asynchronous? Anybody? What is meant by asynchronous? Asynchronous means there is no clock, right? There is no clock. That means all 5 nodes will compute after 1 clock, after 2 clock. There is not periodic. Asynchronous means whenever a node gets update. How a node can get update? Either the link is down, connected is direct link is down, or direct link cost is changed. In that case it needs to recalculate, or it receives an update from the neighbor. Okay, so in any way, whenever it receives an update, only when it recalculates. So that is asynchronous. Clear? And also it is distributed and self-stopping. Distributed means everybody will calculate its own. It will not know the update of the database of others. It will only know through update. So everybody will calculate its own. That is distributed. And self-stopping means what? Self-stopping means whenever there is no more update, it will not send anything to the neighbors. If it doesn't send anything to the neighbors, then there will be no more calculation from the neighbors. So that is self-stopping. No notification received, no actions taken. So these are the 4 properties of distance vector. Now let us see one example, and then in the next class we will go through a hands-on example on this. So first, all nodes have distance estimates to nearest neighbors only. This is called the initialization. See, the time is 0. So at first every node will have initialize its own table. When initialize, it will only update the direct cost, right? So if you can see distance vector of A, see A to A definitely 0, A to B what? 8, and A to D is 1. all other values will be
Infinite.
what?
Infinite, sir. Infinite.
All other values will be infinite, right? See, this is same as the linked state. Did you get my point? Am I online?
Yes, sir.
Yes, sir.
So I need your response. Otherwise, so the initialization is very simple. See, from A, only two nodes. There are two neighbors. So A to B is 8, A to D is 1, and A to A is 0. And for all other nodes, it will be infinite. Okay. Then similarly, everybody will initialize, not shown for all other nodes, but you can definitely do that, because for D, how many neighbors for D?
3 neighbors, sir.
3 neighbors. So 3 values will be 1, 1, 1, and all other values will be infinite. So by this way, every node can initialize. So after the first step, after the initialization, every node will inform the update to the neighbors. That is the process. Whenever this is exchanged, every node will recalculate, but we will show only for one particular node, so it will be understandable. So every node will compute. See, so it is distributed, but we will show an example only for B. It will be easy for you to understand. So it will continue until there is no more update. But let us see one particular example. So B has initialized. See again, B has 3 neighbors. So B has 3 neighbors. So see, A 8, to C 1, and to E 1, and all other values are infinite. Now B will get update from A, E, and C. Agreed? So after getting update from A, C, and E, see how they will get update. A will send its own distance vector, C will send its own distance vector, and E will send its own distance vector. Now what is the new information here? See, B has no connection with D, but A has a connection with D. So B now initially has from B to D is infinite because it has no connection with D. For example, if it receives the update from A, it will understand, it will know that A says, I have distance cost 1 to D. So B will understand, okay, I can go to D through A. So it will then calculate, okay, B to A is 8 and A to D is 1. That means B to D, it will update to 9. But this is the logic, but it will not do like this way. It will apply that algorithm, distance vector, sorry, Bellman-Ford equation. So how that is done? See how that is done. See, so after getting update from A, now B will, A, C, and E, B will recalculate all its entries. All its entries. How? See, B to A initially was 8, right? Now B can go to A. How many ways? Can anybody tell me? 3 ways, right? B has 3 neighbors, so 3 ways. So if it go through A, then it will be like C, B to A, D, A to A, right? If it goes to C, C, B to C, D, C to A. If it goes through E, C, B to E, D, E to A. So in each case, see the direct cost and the cost from neighbor to the destination. Direct cost, cost from neighbor to the destination. Direct cost. So if there are 3 neighbors, that means there are 3 possible values. You can easily calculate CB to A is 8, CDA to A is 0, CB to C is known 1, plus C to A. Now C to A, it will find from C's update. See, C to A is infinite, so it will update, and then B to E, E to A, it will find from E's update. So that is the importance. Now after all things updated, it will find.
এখন টাইম হয়ে যাচ্ছে এর
Okay. Okay.
CD tab.
Okay, fine. Just understand the logic. So after getting updated, then B will calculate its own table, gets updated. So this is one way, and this will repeat. This will repeat continuously. All the calculations done. Now after B calculates its new table. See the original old table, new table. This will be again update sent to the other neighbors. So this is the actually this how distance vector works. This will continue. If you understand this slide only, you can understand everything. So I am not going through the later parts because this slide you have to understand, and this will actually repeat. And then the next class we'll do one hands-on lab. So I am stopping here. Before next class, please go through this example and then come to the class. That will help. So next week, next class we'll do a hands-on example, and then there are some little bit of more theory we'll cover, and then that will end our network layer. Okay. Any question? Okay, so it's already I think 1 minute left, probably. Did you get the question? Anybody?
No, sir.
No, I think
No, sir.
1 minute left. Okay. So at 1:05, the question will be ready to upload, download the question and the previous procedure. Complete in blank sheets. Write your name and ID in each blank sheet. And then after completing the exam, scan and upload as a single PDF. But again, I am saying don't do it in the last minute. If you miss the time, I have nothing to do.
স্যার স্যার
Yes.
আমার এখানে স্যার অনেক ম্যাক করছে বুঝছেন স্যার, যেহেতু মেইলে নেবেন না, পুলটা যদি একটু বেশিক্ষণ ওপেন থাকতো তাহলে ভালো হতো স্যার।
Okay, try your best. Try your best.
ভালো কাজ করেন না স্যার।
যদি লোডশেডিং হয় কি করব তখন?
ওটা case by case. Don't
Make
worry
করতে
right now. Don't worry right now. Okay. Lots of time. Okay, start your exam. If you have any problem, let me know. But there is no explanation about the question. You have to understand your own. Okay. Now question is available. Question should be available.
Yes, sir. হয়ে গেছে।
Okay. Okay, fine. Start. Don't get panicked. The answers are very simple. Not much to write down. No descriptive question. Just you have to understand the concept and write down the answer very short. In case of the headers of IPTR, just write down the name of the fields. You don't need to describe anything. But for the routing question, you have to show the calculation, that binary calculation. So your time is up. Please upload as early as possible.
স্যার টাইমটা কি একটু বাড়ানো যায়?
স্যার একটু বাড়িয়ে দিলে ভালো হতো স্যার।
স্যার প্লিজ একটু বাড়ায় দেন না টাইমটা।
Sir, time take.
Okay,
Sir, time
140,
take.
140. Upload by 140. 5 minutes more. Okay, extra 5 minutes is also up. Those who have finished, please upload. No more upload after 1:40. Okay, after 1:40 p.m. no more upload. So please upload as early as possible. We are almost at the end of the class. I will close the class soon. Please upload as early as possible. Those who have uploaded, just write your ID and name in the message box and then you can leave. Everybody upload, please.
For attendance.
Just give your ID in the message box and then you can leave. Okay, those who are yet to upload, please upload as early as possible. I am closing the class now.